This question here is taken from the March 2013 Edexcel higher tier paper. Okay, so if we take a look at this question here, question 21, it says prove algebraically that the difference between the squares of any two consecutive integers is equal to the sum of these two integers. Okay, so just notice the key words here. We have algebraically, which means algebra, so somewhere down the line we're going to have to use algebra, so symbols such as x or y, for example. We also have squares, so square numbers, consecutive integers, which is the numbers that are next to each other. So if I just underline these key words here, the squares of any two consecutive integers, and it's equal to the sum of these two integers. Okay, so as I said before, consecutive integers is numbers that are next to each other, so we can have 3 and 4, they're next to each other, or 5 and 6. The thing is, you cannot use real numbers to prove this statement here because we have to prove it algebraically. So what I can do is I can call any number x, so that will be our first number, and I can call our second number x plus 1 because that will be the next number up. So those are our two numbers, and it's in terms of x. Okay, so what they've said here is the squares of any two consecutive integers. So these are our integers here. If we square both of these, so x squared and x plus 1 squared, and I'll put it in brackets. Okay, so what they've said here is that, well, the squares, the difference between these squares, so obviously the x plus 1 squared is going to be larger than x squared, and again, if you can't really suss that, just think of an actual example. Think of 4 and 5. Obviously 5 squared is going to be larger than 4 squared. So the difference between these two, so taking the bigger integer squared, x plus 1 squared, minus x squared is equal to, so it is equal to the sum of these two integers. So it's the sum of our original integers. So it's going to be x plus x plus 1 because that is the sum of our two integers. Okay, so all we need to do is we just need to prove this equation here. So starting with the left hand side, x plus 1 squared minus x squared, let's try and expand this bracket out, simplify it, and what we should get is we should get this expression here on the right hand side. Right, so expanding this bracket out here, I can use my shortcut. The shortcut is this, x plus 1 squared. If I square the first term, so the first term in the bracket is of course x, we'll do x squared. Square the last term, so the last term is obviously just the plus 1. That's the last term in the bracket. If I square that, that gives us, well, 1 squared is just 1, so the plus 1. I've left that space in the middle because that's where my twice the product goes. And twice the product just means you do the product of both terms. So x multiplied by 1, that gives us a 1x, and then you just twice it, you just double it at the end. So x times 1 is 1x, and then you just double it at the end. So that's a little shortcut when you're expanding a squared bracket. Just remember that saying, square the first, square the last, and then twice the product of these two. And of course we've got that minus x squared at the end. Okay, so what this equals to is it equals to this. So we have an x squared there, and we have a minus x squared there. So what happens is these two will cancel out. These two will disappear. The positive x squared and a minus x squared. And what that leaves us with is that just leaves us with 2 x plus 1. And of course that is the same as the right hand side, because if you look at the right hand side here, what this actually means, as I've put it as two integers, I'm summing two integers, we can simplify this and this will become x plus 1, and that is just simply 2x plus 1. So of course these two are exactly the same. So that means we have just proved that the difference of any two consecutive, or the squares of any two consecutive integers, x and x plus 1, when you take the difference of those two, you get the sum of the two consecutive integers, and that is the full solution there.